Hello guys, good day to you. Good morning, good evening, good afternoon, depending on the location where you have viewing this video from. You are welcome to our class for today. This is your physics video tutorial, and this is Nobleman Science Tutors Online. I remain Otobo Michael, and you are welcome to our class for today. Please, if you are ready for the class, get your writing materials ready, get your calculators, your notepad, so that you can pull down notes so that when we go through the calculations too, you will know exactly how to follow through. For today, we are going to be looking at escape velocity. We started the tutorials on gravitational field, and we've discussed various areas of gravitational force. So, and in our also last video too, we discussed the Kepler's laws of planetary motion, and we also discuss satellites, artificial and natural satellites. So for today, we're going to be looking at escape velocity. Escape velocity. But before we go to our class, please, if you have not subscribed to the channel, please click on the subscribe button, click on the notification bell so that whenever we upload a new video, YouTube will notify you. Please, we also plead with you, give us a like, give us a thumbs up, share these videos with your friends if you enjoy what we are doing, so that they also will come and enjoy what you are enjoying in YouTube. Please, also, you can reach us via the WhatsApp number that is showing right on your screen. You can join the WhatsApp chat group. If you have any challenge, you post it there, we'll discuss it with you. Is that okay? So please give us a thumbs up, give us positive comments so that you can encourage us. We are working gradually, and so far we've covered a lot of topics in physics, and we hope that in a very short time we'll cover the complete curriculum for WAEC and for our SSC students and those who are in senior secondary school, high college, and all that. Maybe after this video series, we'll go to another areas of physics. We'll review some past questions and we'll do some preparatory classes for JAM students and for other students too. Okay, so right away, let's go to our class for today. We are looking at escape velocity. All right, so in our previous lectures we have treated in one of our previous lectures we've treated a circular motion, and under circular motion we looked at objects that undergo um, circular motion. And in that particular class, we said that when an object undergoes circular motion, it moves with uniform speed. The speed is constant, but the velocity changes. Because why? The direction of the object is always changing as it moves around the circle. So as far as the direction is always changing as it moves around the circle, it also means that the velocity will be changing, because velocity depends on magnitude and the direction. Okay, so if we take this as a satellite that is orbiting the Earth, and if this is the Earth, and this is a satellite that is orbiting the Earth, okay, so we can say that there's a force that is pulling these satellites towards the center of the Earth, and it is this force that keeps the satellite in orbit. All right, it is this force that keeps the satellite in the orbit, and this force is also equal to the gravitational pull of the Earth on the satellite. Okay, so mathematically stated, we can say that, remember that this is the equation we had for um, centripetal force. Centripetal force is equals to mass times the square of velocity all over distance, all over the radius of the Earth. Okay, all over the radius of the Earth. So, we have also seen from our previous class that the gravitational force equals to the product of the masses that are interacting all over the square of that distance, or multiplied by gravitational constant, the universal gravitational constant, which is this capital G. So if you put these two equations together, you are going to have that F this is force and this is force. So you put them together, you're gonna have F is equals to mv squared over r is equals to capital G, the masses, and then product of the masses all over r squared, right? So if you do this, this will cancel this out. So what you have will be v squared over r, v squared, all over gm arrow, because this arrow will cross over. So by the time you do your cross multiplication, you have v squared is equals to gravitational constant g multiplied by mass all over r, and then make v your subject by squaring the both sides. So this is what you have. You have this particular equation. That's okay. So this velocity is actually the velocity that keep the satellite moving around the Earth. So if you are asked to calculate the velocity of a satellite that is orbiting the Earth, this is actually the equation that you will use. Okay, so you can take note of this equation. This is not escape velocity. Please don't get it twisted. Is that okay? This is the velocity of the satellite that is orbiting the Earth. All right. Okay, so as I said, this is the velocity of the satellite that is orbiting the Earth. So now, for a satellite to escape from the Earth gravitational pull, for a satellite to escape from the Earth gravitational pull and not to return back, that satellite must be launched with a velocity that is greater than that required for it to orbit here. So simply put, it means that the velocity of the satellite, the escape velocity of a satellite must be higher than this velocity that we got before. Okay, so and that velocity is defined as the minimum velocity required for an object, e.g. a satellite or a rocket, to just escape the gravitational pull of the Earth permanently. That is what is called escape velocity, the minimum velocity that is required for a satellite to escape the Earth's gravitational pull permanently is called escape velocity. All right, so now remember that from the Newton's law of universal gravitation, we just discussed it previously, we had that the force is equals to the mass of an object, the product of the mass of an object to that of the Earth, all over the radius of the Earth raised to power 2. Okay, or multiplied by the universal gravitational constant. This is the Newton's law of universal gravitation. All right, but the work done in moving a unit mass from a point that's at a distance r from the center of the Earth, work done is equals to what? Force times distance. Work done is equals to force times distance. So if we substitute force into this particular equation, if we substitute this force into this equation, this is what we're going to have. We're going to have that work done is equals to, this is force, this is force, this is force times distance. So by the time you do this cancellation, you will have this this equation, you have this. Okay, you will have that. Now for the object to circle around the Earth, the work done is equal to what? The work done is equals to what? Is equals to the kinetic energy. So right away you bring down, now you will now bring kinetic energy to this particular equation. So as I said, you bring the kinetic energy to this equation. Okay, so this is what you will now have. You will have that kinetic energy is equal to what? It's equals to universal constant multiplied by the mass of the object and the mass of the earth, or divided by r. This is the equation we just got previously, right? So now make v the subject of the formula. Okay, so if you make v the subject of the formula, you have that okay, so yeah, this half mv squared is equals to g, capital G, mass of earth, mass of objects, all over radius of the earth squared. Okay, so this is for that. So now if you make v the subject of the formula, you have that v squared is equals to 2, we multiply everything that is there. Okay, so we have that, we have 2 g me all over r. Okay, this is just r, not r squared, sorry. So typo error. Okay, so this is this all over r divided by m. Okay, so this m will cancel this, so that v squared is equals to 2 g me all over r. Okay, so this is what you have here. Then if you square both sides, you will now have that square root v is equals to square root 2g me all over r. Okay, so if the satellite is launched from the surface of the earth, we have that the radius of the earth will be equals to capital R. So this, you can equally just change this small arrow to capital R to give you this equation. Alright, to give this equation. Now I want you to remember that when we treated the calculation of the mass of the earth, this is the equation we had from this particular equation of gravitational acceleration. We said that gravitational acceleration equals to what? Force all over force per unit area, force per unit mass. Okay, so and then we are able to arrive at this particular equation. You can recall that this, so we had that the mass of the earth is given by acceleration to gravity multiplied this by the square of the radius all over g. So change this small arrow to capital arrow so that you have this. Now you can easily substitute that into this particular equation. So if we do that substitution, you will have that substitute for me, so you have that v is equals to you have that will be equals to square root 2g all over capital R multiplied by me, which is equals to g capital R squared all over what? Capital G. So if you have this, you can count this, will cancel out. One of these arrow will cancel this, so you have one arrow there. So overall, you are going to have, at the end of the day, you are going to have that v is equals to square root 2g r. Okay, so this equation that you have here now is called the escape velocity of the satellite. Know that capital R is the what? The radius of the earth. Capital R is the radius of the earth. So this equation gives you the escape velocity of the satellite. So and that is what we have here. So I just decided to break it down so that you will understand. Now this equation is also equal to this. So depending on the equation that you are given, you are either going to use this or you use this. If you are given the mass of the earth, you use this equation. If you are given just the radius without the mass of the earth, you use this equation to solve. So depending on the equation that you are given, or depending on the equation that you are given, you use any of this equation to solve. So this is what escape velocity is. Is that okay? So right away, we are going to solve some problems so that we see how questions are presented for students. Questions on escape velocity comes for students. All right. So I hope this is clear. So let's look at some questions now and see how we can maneuver and solve the questions. Okay, so this is question number 1. This question says that calculate the escape velocity of a satellite launched from the Earth's surface. Take g is equals to 10 meters per second square and radius of the Earth to be 6.4 times 10 raised to the power 6 meters. So in this particular equation now, we know that the escape velocity v is equals to square root 2g capital R, or v is equals to square root 2 capital GM E all over R. So in this particular question, which of the equation are you going to use? Looking at the variable that is given to you, this equation suffices, because here you are given G, you are also given R. So this equation suffices. So you see V, substitute into that equation, so V is equals to square root 2 multiplied by 9 multiplied by 10, okay, multiplied by 10 times 6.4 times 10 raised to power 6. Okay, so you can work that out. Okay, so if you work this out and you find your square root, you have 1.13 times 10 raised to power 4 meters per seconds. Okay, so this is pretty simple. Is that not? This is pretty simple, and this is actually how the equations come. It's just for you to know which of the formulas to use, and then maybe look for the variables that they are asking you to look for. Okay, so let's try and solve another problem too. So this is question number 2. Here, the escape velocity of a rocket from the Earth is 11 kilometers per second. Take the acceleration due to gravity to be this. Calculate the radius of the Earth. So this one is in another form. Here you are asked to do what? To calculate the radius of the Earth. So which means that in this particular instance, you will be making the radius subject of the formula. Remember that V is equals to square root 2g r. Now you are giving the velocity, which is the escape velocity. You are giving g, but you are not giving r. Okay, so here you are given that velocity is equals to 11 kilometers per seconds. So you have to convert this to meters per seconds by multiplying by 1000. So that gives you 11,000 meters per seconds. Okay, so you are also giving your g to be equals to 9.8 meters per second squared. Okay, so now I want to look for arrow, which we are not giving. So make arrow the subject of this equation by squaring both sides of this equation. You have that v squared is equals to 2gr. If you square both sides, which is what you have, so arrow will be equals to v squared all over 2g. All right, so when you substitute into this equation, you have that you have 11,000 squared, 11,000 squared divided by 2 multiplied by 9.8 given. So if you work that out with your calculator, punch that out with your calculator, it will give you 6.2 times 10 raised to power 6 meters. So from this you see that questions on the escape velocity, they are not really that difficult. It's just for you to know the equation to use, and then you can solve any problem that you wish to solve. I will encourage you to please check your textbooks and solve as many problems as you can, because the more problems you solve, the better understanding that you will have. Is that okay? The more problems you solve, the better understanding that you will have. So try as much as possible to solve as many problems as you can. This is another question. Say calculate the mass and escape velocity of a planet B with diameter 1.28 and 10⁻⁷ meters. Take g to be small g to be 9.8 meters per second square and capital G to be this. Okay, so if you look at this question, it is a little bit of variation. Okay, it varies a little bit from what we've done before. Here you are giving diameter, you are giving capital G, and you are also giving small g. Alright, so first and foremost, we are going to start with converting this diameter to radius, because we need this radius, not diameter. Okay, so radius is equals to what? D over 2. Okay, this is actually a JAMB question. I didn't put JAMB here, but it's a JAMB question. So this is a JAMB question. Alright, so when you do that, you have that. You will now divide this by 2 first to convert it to radius. Alright, so divide that by 2 so that you have your radius. So this gives you 6.4 times 10 raised to power 6 meters. So this is your radius R. Okay, then you are giving your G to be equals to 9.8 meters per second squared. Then your capital G is given to you to be equal to 6.67 multiplied by 10 raised to power minus 11, okay, Newton meters squared per kg squared. Alright, so these are what are given to you. Now you are asked to calculate the mass. Now from our previous equation, we had a mass. The mass of B is given to you to be equals to what? G R squared all over capital G. Okay, so when you substitute into this equation, you are going to have 9.8 multiplied by 6.4 times 10 raised to power 6 all squared divided by 6.67 times 10 raised to power minus 11. Okay, I hope you are following. So by the time you work with this out with your calculator, you have the mass of B. Mass of B will be equals to 6.0 times 10 raised to power 24 kg. So this is mass of planet B. Okay, so this gives you the mass of planet B. Now the escape velocity V is given to be V is equal to square root of 2g r. The radius of the earth, you have known it already, to be 6.4 times 10 to the power 6. So if you substitute into this equation, you have square root of 2 times 9.8 given to you multiplied by 6.4 times 10 raised to the power 6. So escape velocity, if you work that out with your calculator, you will have 1.12 times 10 raised to the power 4 meters per seconds. Okay, so guys, that is it, and this is how most of the questions will come on this, and this is how you go about it. Know how to relate all the equations together. This is the equation for the mass of the moon or of any planet, and then this is a escape velocity. All right, so I hope this is quite simple and you can relate well with this. All right, so thank you so much. Let's go to your test page. So please guys, these are questions for you to try your hands on. Okay, these questions relates most of the things that we've discussed. Remember the equations for the force of gravitation between two masses. So with that, you can be able to solve this question looking at the distances apart of the masses, then calculate the force per unit mass on the earth surface. Okay, so we had the equation for force per unit mass. Remember that. Okay, we had the equation for force per unit mass. I know that force per unit mass equals to what? Acceleration due to gravity, and then you know the equation for it. So just go through and then you should be able to solve these problems easily. So guys, thank you so much, and this is where we are ending our class for today. But before I go, please, if you have not subscribed to our channel, what are you waiting for? Please subscribe to the channel, give us a like, give us a thumbs up, give us positive comment, help us to share this video in your various social media platforms, and so please, you can reach us through the WhatsApp number that is showing on your screen. This is Noble Mind Science Tutors Online, and I remain Otobo Michael. We hope to see you in our next class. Thanks.